The topic for this community call is making your AI think before doing. And in traditional fashion, we have an incredibly packed agenda. For the past few months, we've done a very good job of staying on time and ending within the hour. However, I'd be willing to bet that this is going to go a little bit long, so just a heads up in advance. If you do miss anything in the call today, we have all this recorded and it'll be available on our platforms in the next, let's say, day or so here. If you look at the agenda that we have here, we're going to start off by talking about query plans for accurate and steerable AI on data. And then we're going to work through PromptQL versus reasoning models, and then PromptQL natural language API. We're going to continue talking about PromptQL for the majority of this call, and we'll do a few topics towards the end that are focusing on the Hasura DDN, or the data delivery network, which is really the underlying API that powers PromptQL to begin with. As a reminder, for any questions that you have in the call, on the right-hand side, you're going to see an engagement section. You'll see a Q&A. So please, if you have any questions for any presenters, drop them into that Q&A section, not into the chat. That way we can actually bring them up on stage and get them answered live and in person for all of you. We are curious about where you're joining from. So in the chat, not the Q&A, but in the chat itself, if you wouldn't mind just dropping where you're from, because we're excited to see people kind of from all over the place. I myself am joining from San Francisco. So if you're around, let me know. To begin with, let's go ahead and jump in for our first talk, which is going to be on query plans for accurate and steerable AI on data. I'm going to bring in the PromptQL product manager, Anushrit. So Anushrit, if you'll go ahead and join me on the stage, please. How are you doing?
Hey, folks. Hey, Rob.
Man, that PromptQL hoodie looks good. And as we're going to learn throughout the remainder of this call, I am one of the only ones that did not get the memo of, hey, wear your hoodie. So I'll have to have that in my go bag ready to go every time that we do one of these calls. But yeah, I'm going to get out of the way because, like I said, we have a packed agenda, and I'm going to turn it over to you.
Awesome. Thank you so much, Rob.
Yeah.
Let's talk about PromptQL query plans. How can we make our AI think before doing? How can we push our AI's accuracy and controllability and steerability towards 100%? How can I make my AI do exactly what I want it to do? How can I make my AI explain to me what it is trying to do, and then how do I course correct my AI so that it can get to the task that I want it to do? That's what the PromptQL query plans are. But first, we need to understand why query plans are even important, right? So let's look at an AI system which is supposed to work, right? This is Gemini on Google Gmail, right? And I ask it a question like, how much have I spent on Uber in 2024? And it says that you have spent $176 on Uber Eats. So it must have done something in the background to get to this answer. So I want to control my AI. I want to tell it, no, I'm looking for Uber trips. So I ask, how about Uber trips? It says that you have spent $73 on Uber trips, but that number does not seem believable to me, right? Because if I were to do this myself, I would have searched emails, filtered them down by Uber receipts, and then gone through each email one by one, taken out that exact receipt amount, then summed up those amounts and come up with an answer, right? That's what I would have done. But Gemini doesn't tell me how it got this number. So I ask it, like, how did you get this response? And it says that I found an email containing an Uber receipt dated January 23 for $18. Then I also found some emails dated April and dated December. And then adding these together, I got this number. But I do not, I do not think that's right? Because it's completely inaccurate. Just in the last month of 2024, in December, I have 30 Uber receipts. That's easily more than $73. Now for the entire year, it's going to be a lot more than that. So neither has this AI given me an accurate answer, neither it has given me the right explanation, and there is no way for me to control this. So how do we make AI more controllable? How do we make AI give us the right answer, right? And the problem is with in-context data retrieval and processing. Like, think about how Google might have built Gemini, right? They must have taken all your emails, vectorized them, put them in a vector database somewhere, and then created this RAG pipeline where when you ask a question, they might do some kind of a semantic search or a lexical search or a mix of both, and then find the relevant emails, give it to the LLM, and ask it to answer that question. That is the problem. The problem is with this in-context data retrieval and processing. They might be using the best vector database under the hood. They might have the best algorithms for search. But as soon as they connect these things to their LLM, that's when everything starts falling apart. Because the problem is with these rigid pipelines that they have created. Their AI is not creating pipelines on the fly, which are the most appropriate for that specific question. They are using these rigid pipelines of if a user asks a query, do a semantic search on all the emails, find the relevant 3 emails, I guess. That's why they had 3 emails in that example, and then give it back to the LLM and ask it to answer that question. That's the problem with rigid pipelines. And that's why none of these approaches that we have, which rely on rigid pipelines, work. All of these in-context methods and rigid pipeline methods, where basically we are asking a system to give the LLM all the data that is retrieved by some kind of a query, a semantic search query, a tool calling query, a text to SQL query. And they're expecting the LLM to answer that question. And the LLM is not really creating this pipeline on the fly, right? It's just expecting it to work just as it is for any kind of user query. But they give a free-form text box to the user can ask any question they want. So what is the solution? So if you think about it, LLMs are really good at planning, right? If I were to ask an AI assistant a question like, don't do it, just tell me, if I have my entire email history, how do I find the total amount I spent on Ubers, right? Just give me a plan. Don't do it for me. Then AI would think about it and come back with a response that, okay, maybe you need to first filter down your emails which have like Uber in the subject line, Uber receipts in the subject line, so that I can narrow down my search space. Then maybe you go email by email, find out what is the receipt amount in each email. Keep saving that receipt amount somewhere because you won't remember every single thing. Then you sum up each receipt amount deterministically, and that's how you get that exact number. So this plan an LLM could have generated, right? I don't have to. I can rely that much on the LLM, but LLMs are not good at sticking to that plan. Now, if I ask the LLM, okay, now can you go ahead and execute that? It really depends on what is the pipeline under the hood, right? If the pipeline is a semantic search pipeline, then what is that entire plan about, right? LLM cannot really follow that plan. So you can use your LLMs for creating these plans, but not expect the LLM to work on sticking to that plan. And that's because LLMs are also not good at processing data in context. If I were to give all of these emails, let's say at any part of this pipeline, right? Either I can't give all the emails to the LLM. I can't filter down the emails by Uber receipts first and then give it to the LLM. There might be thousands, right? So at what point do I give the data to the LLM to expect it to answer the question? Also, even if, let's say, I extracted the exact Uber receipt numbers and then gave it to the LLM, I can't expect my AI to do the sum correctly. So that's why at no point LLM is good at handling the data itself. So what is the solution, right? For us to be able to answer a question like this, like as complicated a question like this, right? Like some of you have seen this kind of a question before, where imagine an internal customer support assistant for our internal teams. And you ask it a question like, find tickets raised over the last 7 days by enterprise customers regarding service timeouts where our SLA was not met. Now, just this part of the question, unless I have an exact pipeline under the hood which can answer this question, I cannot expect my AI system to be able to answer it accurately, right? Because it's a complicated question. There is data coming from multiple data sources. There are different types of queries that have to be done, a mix of structured queries and unstructured queries. There's some kind of semantic understanding inside of the tickets that my AI needs to do. There's some level of calculation my AI needs to do. And then if you take the second part of the question, where the AI also needs to take action, just forget about it, right? None of this will work. But how do we make an AI system which can answer any flexible question as complicated as this one that it can reliably answer? We tried reasoning models, right? And we'll talk about these more in this community call. But we tried these reasoning models, thinking because they plan before doing, right? They think before doing. And we gave them multiple tools. Like we gave them a data retrieval tool. We gave them a Python tool to do calculations accurately. We gave them a bunch of tools and expected that they might do it correctly. They come up with plans of how to orchestrate these tools. They try to fetch data, try to process data, but all of that is still happening in the LLM's context. And that's why even these best of the best systems don't work. So what is the solution, right? So the solution that we thought with PromptQL was to separate the query planning and the query execution part, which is let the LLM think about how to approach this problem. Right? What are the steps? The steps that I said, right? Like first, I will find all the emails where over receipt is mentioned. Then I'll go email by email, fetch out the receipt amount, save it somewhere, do the sum, and then come back with an answer. That's a great plan. So let's separate that plan from the actual execution of that plan, and do not let the LLM touch the execution. So if I were to ask you as engineers, can you write code to specifically answer this one type of question on your database? Forget about AI. You'll be like, yes, I can write code, which will 100% deterministically work on that specific question that you asked. So why don't we ask the AI to do the same, right? They are good at coming up with these plans. They're great at writing code. So why doesn't my AI just do that? And then once it's done with writing code, that's where the job of the AI stops. That's where the job of the LLM stops. Now I can take this code and execute it separately, completely separately in a sandbox, and then expect my answer to be 100% accurate, right? So imagine what if you could have these kinds of 100% accurate task-specific programmatic agents, right, for any user query. So imagine if your AI could spin up these task-specific programmatic agents and execute them for any user query individually. That's how you can get 100% accuracy and steerability for your AI. And that's the entire design behind PromptQL, right? Which is separate the query planning from query execution and let your AI just implement task-specific agents on the fly, and then execute those agents completely outside of the LLM scope. So let's just look at how this can actually impact your performance, right? Like, for example, take this unstructured query. This question comes from the frames benchmark by Google, where these are a bunch of complicated multi-hop questions on Wikipedia data. And you can ask a question like, if my future wife has the same first name as the 15th First Lady of the United States mother, and her I'm just going to let it run first. If my future wife has the same first name as the 15th First Lady of the United States mother, and her surname is the same as the second assassinated president's mother's maiden name, what is my future wife's name? Complicated question. Probably answer comes from 4 different Wikipedia articles, right? First, my AI needs to understand who is the 15th First Lady, then who is their mother, what is their first name, then who is the second assassinated president, who is their mother, and then what is their maiden name, and then what is their maiden name? That will be the last name for my wife. So I need to do these multi-hop kind of things. If I have one rigid semantic search pipeline, I can't expect my AI to work. So see what PromptQL does, right? It breaks it down into steps. That okay, first I need to just understand who's the 15th First Lady, and then find her mother's first name. So I'm going to search for articles about the 15th First Lady of the United States and extract information about who she was and her mother's name. It says that, okay, Harriet Lane was the who appears to be the 15th First Lady. Now let's specifically extract her mother's first name. You see how it's breaking down the task, coming up with these individual task-specific programs on the fly. That's what it's implementing under the hood, right? That under the hood, it's basically doing semantic search on the different Wikipedia articles. Then it's also asking an AI system, specifically delegating this task that, hey, can you extract the full name of Harriet Lane's mother? Only extract if this information explicitly stated in the text. You see how it's breaking this task and going step by step to answer my question. This just gives me so much confidence that the answer that it comes up with, it's going to be accurate. And that's the answer I was looking for. Jane Barrow. That's exactly that's the right answer. And it's continuing on and doing a double check and verification, but that's great. I don't need to do it. But okay, so that's an example for like unstructured data. But what if you have structured enterprise data, right? And you want to do this kind of query planning and steer your AI towards the right answer. So I want to know, let's say, for example, I have all of my customer data in some few databases. I've connected that to an AI system, and I want to understand who are the 5 most important organizations that we serve. But we serve a bunch of organizations. Each organization has a bunch of users, and each user has a bunch of projects, and we bill on those projects. So I want to understand the 5 most important organizations. But first, you'll have to find out how many unique organizations we serve, right? And my organization ID data is messed up, so you can't just use that. So find out the number of unique organizations we have first, and then tell me which are the 5 most important organizations. So if I ask this to PromptQL, PromptQL will say, okay, to answer this question, first let's count the unique organizations, right? By grouping users based on their email domains. That's smart. Okay, email domains is a pretty good way to find unique organizations. And exclude common email providers like Gmail and stuff like that. Okay, that's great. It says that you have 19 unique organizations. Now let's identify the 5 most important ones by looking at their activity and revenue metrics. Okay, that's a fair assumption. I gave a very vague request of most important. That means nothing to anyone. But PromptQL is like, okay, I'm going to make this assumption. Best part about PromptQL is that it can understand if it runs into an error and it can heal itself. Okay, so it says that I'm going to count total projects, total API requests, sum up invoice amounts, and look at the error rates to come up with this answer. Okay, that's fair, but that's not what importance means to me. So how do I tell my AI that, hey, can you actually look at something else? Okay, I'll just stop this execution. I'll edit this query plan. I don't know what's happening here. Let me refresh the page. 1 second. Okay. I'll just continue from here itself. Let's edit this query plan and ask my AI that, hey, can you actually not look at all of these? Can you just sum up the invoice amounts and sort for top 5? But before that, can you actually filter out organizations that have less than $20,000 average revenue per project, and filter out organizations that have less than 3, or let's say less than 20 support tickets. First do that, and then sum up the invoices and give me a top 5. No need to look at error rates. I think that's what importance means to me. So I can edit my AI's query plan. I can edit my AI's brain and ask it to run exactly that instead. It says that, okay, for each organization, I'll calculate the total invoice items, count number of support tickets, calculate average revenue per project, and then have average revenue per project more than 20,000, at least 20 support tickets, and then show you the top 5. It's figuring out what the issues are while doing this analysis. But you see how I can edit my AI's head, AI's brain, and then make it do exactly what I want to do, but also let it continue figuring it out exactly how to answer that questions. How is the data under the hood? It says that we're getting some support data, but we're not getting the revenue data. Let me figure that out, why that is. So that's all great. Now, final ranking about the most important organizations by combining revenue data and support engagement. Perfect. Yeah, that's exactly what I want. But you see how it was easy for me to steer my AI to get to this final answer of my 5 most important organizations sorted by total revenue, but they have this criteria was a little too strict, that revenue per project is more than 20,000. That's why we were not getting the data. So it flexibly adjusted to that. Support tickets is this. So this is how I can get my AI to be 100% accurate and 100% steerable for exactly what I wanted to do. So try out PromptQL, and would love to see the kind of AI systems that you build with PromptQL, which can be controlled with query plans.
I wanted to ask a question to you about the editing of the query plan itself, or kind of the steering of the instructions. So if I were to continue in that thread and have a deeper conversation with the AI itself, would my steering be part of the context going forward, or would it be forgotten?
Say it again.
Would the steering that I do be part of the context for continuation in that thread, or would it be forgotten? So like if I go in and edit and change things around, is it going to remember that going forward? Is my question.
Yeah, exactly. So in the same thread, it will remember, because it's part of the context, right? The feedback that I've given it, that, hey, you did this incorrectly. Could you have done that instead, please? That's so right. That will be part of the context. Yeah.
I think anybody that's interacted with the LLMs has found themselves repeating things over and over again. So it's nice to know that you can say it once and that'll be all you need there. All right. We do have one question here, which, Harsha, if you're hearing us backstage, if you want to throw that question up on the screen here. previous folks were playing with our toys and we like them a lot. So the question is, how good is the model in terms of performance optimization?
Okay, so that's an open-ended question, right? When you say performance, I'm not sure what you mean by performance. One way I interpret performance would be the query performance, in the sense that if there's a lot of data that needs to be fetched and then processed, how well will the AI optimize on what's the most efficient way of doing that? So that has less to do with our LLM itself. It has more to do with the architecture and how we connect the different data sources. So by design, what we try to do is we try to push down as many operations as possible to the database itself, where it's going to be the fastest. Like any kind of filters and joins and aggregates and group bys, we try to push those operations down to the database so that you get the maximum performance. But let's say if I want to do a cross-domain join, or if I have a query, like a look inside my support tickets and tell me if they're about performance issues. So there's kinds of queries where the database can't do anything, right? You have to pull that data. So that's where what PromptQL will do is will break that task down and use its different primitives to answer that question. If it's a computational task, it'll use just its Pythonic program to answer that question. If it is like a semantic kind of task, it will not try to pull all the data into its own context and try to answer it. It'll delegate that task, break that task down, delegate it to different LLMs to do it. So PromptQL keeps, like, the entire architecture ensures the performance is the most optimal for such a system. But if there's a more specific question, I would love to answer that.
Gotcha. Awesome. And we have our second question here, which is there a way to provide PromptQL with database context?
That is the entire architecture.
That's
the entire point of DDN, which is basically, so DDN is the data access layer, which PromptQL runs on top of. So you connect your data sources to DDN, and DDN stands for Data Delivery Network. So once you connect your data sources with DDN, DDN introspects those data sources, pulls out the schema, creates this thing called the super graph, which is like a unified schema across all your data sources. So it already does that. Now you as the developer have the ability to enrich your metadata, enrich this super graph with relationships across databases. You can also enrich it with semantic descriptions, not just at like a table level, but at a column level, at a relationship level. You can say, like let's say a table which is named ACCT means nothing to the LLM, but you can say this is this table has the account ID for our customers based on XYZ. The typical account ID looks like some like 3 letters underscore numerical values, stuff like that. So all of that, these kinds of semantic descriptions, you can add to the metadata. So yes, there is a way to provide PromptQL with database context, and that is part of the supergraph architecture.
It's probably worth saying as well, right, that this is not just database context, but it's also APIs. So, if I have a function that's going and calling some kind of data, I can have a JS comment in there or whatever my, preferred language is to kind of provide that extra context for the LLM as well. Yeah, awesome. All right, we do have a third question. This is the last one that we'll answer live, and we'll go to the next section. So the question says, we do have explain and analyze commands. Some situations where materialistic views would be helpful. Different kinds of indexes are involved. So will the PromptQL be able to identify top queries coming to a database, propose a set of indexes that are missing or are not used well? So I think essentially what we're talking about here, right, is using PromptQL to analyze more efficient ways of optimizing the performance of the VB itself.
Interesting question. So I know there are speakers who are more technical than I am, and they would be able to answer this question much better. But we have been seeing the use of PromptQL to build more efficient like data architectures. So yes, my intuition says yes to this question, but I would still I would bring this question back up again once like we have Abhinav or someone on the call.
Awesome. If we have time, we'll come back to it. But Pawan, you can keep your question over there in the chat, and we'll come back to it. Anushrad, thank you so much, man.
Thank you. Thanks, Rob.
All right, folks. Let's see. Before we go to the next section, I'm going to go ahead and make a quick plug for our upcoming community call that we have on March 27th. And the topic is going to be, can you make AI 100% deterministic? you can't tell from everything we've been talking about in this community call so far, if you've been tuning into all of our information on PromptQL, is really about the fact that we need AI to be accurate and repeatable in terms of the results that come through. If you scan that QR code, you can sign up for the next community call, which again is March 27th. I'll leave that there for just a second before I go to the next slide, which is an announcement about one more particular event that we have coming up. So if you were on the call last month, you would have found out that we are having our first in-person HasuraCon for 2025. It's going to be here in San Francisco, and the topic is going to be Enterprise AI Beyond the Hype. If you're an individual contributor here and you see a lot of value in what's being discussed and talked about, we'd love for you to put this in front of your manager and in front of your business leaders. So scan that QR code, throw that information out there, and we'd love to see you here in San Francisco in just a couple of months. All right, our second talk today, we're going to go ahead and bring on a familiar guest to the show, Tiru, to talk about PromptQL versus reasoning models. Tiru, how are you, sir?
I'm good. How are you, Rob?
I'm good. I'm glad that you got the same message about what to wear. You know, I think we're both wearing the same shirt. Everybody else is in this PromptQL neon, and we're just, you know, trying to be as basic as we can here. I have a kind of a loaded question before we start here. Reasoning models. For people that aren't really familiar with what a reasoning model is and how it's different from an LLM, could you maybe provide a little bit of context about that before we dive in?
Yeah, so these are models which are trained to think, basically. So they will have some internal optimizations where given a question which does seem like having a bit of like thinking components to it, or like composing different steps together, it takes its time to like figure those things out rather than just trying to generate text as soon as you get a question. So these are like reasoning models.
Awesome. So we're going to see how PromptQL compares to those, right?
Yes.
All right, cool. Let me unshare my screen and I'll get out the way.
All right, folks. So yeah, so we're going to benchmark top reasoning models out in the market today, like Claude O and O3, and we'll see how it performs with and without PromptQL. So PromptQL is not a LLM. PromptQL uses LLMs to do data retrieval and solving data problems, and we'll see how without using PromptQL, what kind of performance we get and what it looks like in PromptQL. So let's start with a very simple question, which is what's the average time of resolution for all support tickets? Very straightforward question. And there are a couple of notes to help with few edge cases like if it's not a closed ticket, then use a certain time, use time zone as UTC, etc., etc. The setup here is like about 150 tickets, and the number of comments within those tickets is about like 250. So not a lot of data actually. And the question is also pretty straightforward. So let's see what happens with this kind of a question. So to actually analyze the power of a reasoning model, what we can do is get rid of all the other things around data retrieval and just give all the data that is required to compute an answer into the prompt itself. Like it could be in the system prompt or it could be in the user prompt, and something of the sort that you can see in the screen here. Like you're an assistant with relevant data in your context, and you have support tickets and you have support ticket comments. So these are like parameterized variables, and we put in a JSON of all the support tickets and support ticket comments here, right? This way we can compute like what exactly is the reasoning power and the computational power of the LLM itself, and not worry about like how it's actually connected to data systems and if that is efficient or not. So this is called an Oracle prompt. So for the previous question, which was pretty straightforward, not a lot of data, you would assume that the Oracle prompt actually gives you the right answer. But the reality of these techniques, right, which we call in-context methods, where the data is in the context of the LLM, is that all the answers were wrong, right? And the variance in the answers was like 50% or so. Like sometimes it would just give a double or even half of the actual truth. And sometimes it would be closer. And after trying it a lot of times, the closest it got was when it actually generated a program but hallucinated one value. So I just want to show you how that looks. So in one of the attempts, you would see that this is with O1, which is the best which was the best model at that time. Like a few days ago, I think new models have launched since then. Haven't tested it with that, but O1 is pretty solid. So what O1 does is it gives you a Python script. Whenever there's a complex computation, O1 is smart enough to kind of give a Python script instead of doing in-memory magical computation. And you would see that this looks pretty good, like it copied all the data from the context into this program, right? And it's pretty impressive that it actually got everything in the program, or so it seemed. And then it does the basic computational logic as was mentioned in the prompt. It actually did not run this Python program, but maybe in the future it could run this, but it's fine. I copied this program and I ran it locally. And what happened is a very interesting thing. So let's go back here. Like I mentioned, it hallucinated one value. And if you look very carefully into the data that you've supplied in the prompt and the data that has been copied inside the program, you would see that one ticket with ID 241 has a different assignee ID in both sides and has a different created at time, right? No idea where this came from, but this is like one of the like I think everybody would agree that LLMs do hallucinate, and at this scale, like about 150 tickets, it did hallucinate a value, and that changes the computation of the final answer, right? So this is just an example to show that in context methods will always have uh, can have like very complex or like very hidden problems that you can't see from the answer itself at a face value. So that brings us to the question of like how much can you trust your AI, right? So trust in AI then becomes a function of few things, even could be many things. One of which is the size of data in context. At like what point, like at how much data can you actually have in context so that you are confident that the LLM would not do random things, hallucinate, etc. Is it 100 tickets? Is it 200 tickets? Is it 1,000 tickets? And also, like, what is the complexity of the task, right? Will it be able to perform like complex calculations? Will it be able to follow like complex decision trees, rules, etc.? Would it be able to like interleave various different types of operations? For example, from a batch of data, extract a particular value and then use that value to do further computations and so on. So there is a lot of like composition happening in context. So these kind of things makes you question like how much can I actually trust my AI? So is there a framework around it? Right? So this is where our benchmark with PromptQL is supposed to show you some insights into the behavior of LLMs and the behavior of PromptQL. So as you saw in the previous question, the database for these experiments are basically two databases. It has support. One has support tickets, comments, and the support users, and the other has all the projects and billing and project-related data. We chose like different types of tasks. One task is like a prioritization of open support tickets based on multiple factors. For example, give me the top 5 tickets that I should prioritize based on the category of tickets, which could be downtime, bug report, feature request, etc. The second could be like what is the plan of the project, right? Is it a advanced tier project, paid project? Is it a free project, and so on? A third rule could be like prioritize based on the amount of revenue that was contributed by this project. So there's like so many factors that you can add to like a prioritization system, right? So this is a complex task. The second task is just a parameterized version of the simple question that we saw. Like give the average resolution time, and this could also be made more complex by adding like give the average resolution time of only like enterprise projects, give the average resolution time of only downtime related projects, and so on. So a lot of variations of that. And the metrics that we wanted to observe were accuracy, like how much did it get right, and repeatability, which is like if you run the experiment multiple times, how many times is it getting the same answer? Now, if you just look at the LLMs, the top three LLMs as of date were as of date at that time were like Claude 3.5, O1, and O3 mini. And we can see that as the complexity level increases for each question, the accuracy also steadily goes down, right? This is true in general, and this is expected as well. There's a lot of computation that happens for more complex tasks. And if you look at repeatability, each of the columns is like the same. It's like a repeated run, and we can see like it's not all repeatable, right? Like depending on the size of the data, we see like there are a lot of runs where the answer is very different from the real answer. Especially if you look at a high number of if you do the computation on a high number of data, then like the answer is very different each time. So this is where as we can see that there are a lot of issues with this kind of an approach, like using tool calling or using in-context methods. There is a lot of issues, and hence the PromptQL architecture is to separate the plan building with plan execution. We saw it in the earlier presentation as well. And just to reiterate the two systems in conventional systems, which will use in-context methods. If you had to do a complex task, then, for example, prioritizing open support tickets, the first step would be to query support tickets data, bring that back into the LLM. And then for each of the tickets, get the project info or any other related info, bring that back into the LLM, and then run the decision tree, right? The decision tree could even use Python if that's available as a tool in the LLM. So a lot of data is getting into the context, which means that you could have the kind of issues that we saw in detail with the simple question, where some data could be missing, some data's actual values could have been hallucinated, and in general, like a wrong computation could have even happened, right? So the rule following could be very different than what you have actually given in the prompt. So these are the issues with conventional systems and in context methods. And by separating the plan and the execution, which is what PromptQL does, you wouldn't have this problem. Why? Because once you've created the plan, the execution of the plan is completely deterministic, right? It's writing an agentic program, and that program accesses data, stores it in memory, does a computation in the programmatic environment, and then does the next steps and so on. So there is no basically there is no reason, there is no scope of like missing some data because of LLM or something like that. It's a completely deterministic programmatic environment. And if we then compare PromptQL with the other systems that we saw earlier, PromptQL here is using Claude 3.5 Sonnet actually. We observe that the accuracy here is 100%, near 100%. And this was with the complexity level. And if we average it over all complexity levels, we can see it's again 100%. The rest of the systems are far below. And if you look at like just the high complexity tasks, right, like choose the most complex version of the questions, then the difference gets even wider. Like the other systems without PromptQL are struggling a lot more in this case. But for PromptQL, it doesn't matter, right? Because once it's generated the plan for the questions, the execution of it is like very deterministic. Same thing with data. There are no data issues anymore because there's no large data in context. Everything is happening at a different layer altogether. So it's immune to any issues with large data sets. So that was the presentation that I wanted to share. And if you would like to learn more about the benchmark as well as the design philosophy behind PromptQL, you can go to this link. And with that, I will stop. Any questions?
Thierry, thank you so much. I'll talk a little bit with you here just before we shift over to the next segment in case any questions come through. There were a couple that happened earlier on, but they're a bit more technical in terms of like the GraphQL schema and that kind of thing, which we know Abhinav is going to be talking about in his section coming up. So we're going to save those questions for him. But if anybody has questions about what Thierry's just shared, go ahead and throw them in the chat. And if none come through in the next few seconds, then he will answer them via text there as well. All right, Thierry, have a great day, and we'll see you soon. All right, folks, let me share screen. So I would say everything that we've done so far in the first kind of 40 minutes of this call has been focused on looking at PromptQL from an academic perspective and kind of talking about essentially how we're outperforming other ways of doing RAG and agentic access and those kinds of things. What we're going to do for the remainder of this call is actually focus in on some feature and product updates that come through for PromptQL. We're going to start with one by bringing on Abhinav, who's going to talk about the PromptQL natural language API. I know a lot of us are excited about this because we've been seeing things in terms of a UI, but now we get to see things in terms of an API. So Abhinav, you want to join me on stage? How are you?
Hey, Rob. Nice to be back here. It's been a while.
Yeah, it's been a while. A lot of us, long time looking forward to an API that we can start taking PromptQL and playing with our own, client applications, whatever they may be. As nice as it is to do it inside of the console, inside of the UI, I'm sure people are very excited to hear about the API. So I'll turn it over to you.
Yeah, for sure. I'll jump right in. And let me present. All right. So as Rob was saying, we have been seeing a lot of lovely demos of how to use PromptQL via our UI. And obviously, there's a lot of work and features that have gone into the UI, which like really enhance the value prop of PromptQL. But we have been getting requests from a lot of folks who want to build their own experiences powered by PromptQL. So they've kind of been looking for a way to just like send some questions to PromptQL, get answers in a nice structured format, and they can then like sort of embed them in their own applications. This is something we recently released. It's a natural language API. It accepts like some basic credentials, the DDN endpoint that you're going to use. So whatever is your Hasura project, the URL for that. Any system instructions you want to give to PromptQL, like, hey, respond in a particular way, or like make sure to watch out for these kind of questions, or use these kinds of like plans when faced with questions like these, what have you. And then you pass basically the list of interactions, like the interaction history so far. So for example, for the first interaction, all you would pass is like, hey, user send this message. And then it's like, hey, can you answer this question? And then the API will respond with like, okay, this is what I'm going to do in response. This is my plan. This is the code I'm going to write. This is the output of the code. And here is my final answer. And then like once you have that response, if you want to like use the API for any follow-up questions, you would end up let me zoom in just in case. You would end up like plugging those, like the history of what the API gave back in here, and PromptQL is going to give you like a follow-up answer. So it's very similar to how like typical LLMs do, and like of course there's like a way to stream what's happening. If you don't want like a one-shot response, so you can set this flag to true or false. So let's just look at the API in action. So here's a sample project that I have, which contains like the some support ticket data that we have been like working with so far, and you can also pass like any headers you want, like for example auth credentials and so on to it. You can give system instructions. I like Pirate, so here's mine. And so we can, let's say we ask a question for which user creates the most support tickets. And let's show with like stream false so that we get like a better sense of the response. Okay, so you see that like it's talking like a pirate, and then it tells you like, hey, this is the plan. This is the code it wrote. This is what the code returned, and this is like the final output it gives you. And it's saying that it has like created an artifact with this identifier, and so that artifact is also available like as a side output in the API. And this is a structured artifact, so you can basically, if you wanted to render like this table in a better fashion in your UX, like this is already available like structured out of the box. So this is how it works. And similarly, if you set to stream equals true, it's going to do the same thing, but give you like incremental updates on what's happening. So this is like if you want to, let's build a streaming UI. That's about it. Here is a let me just put this on the screen. Here is the link for the docs. If you want to try it out, here's a QR code which points to that link. But yeah, that's it. Back to you, Rob. You want to jump back in? Yeah, awesome.
Awesome. Also, don't look in the chat because we've been just trashing your bear blah auth strategy and your system instructions. So well done. We did have a couple of questions that came through earlier on that we're going to talk about. So one that came up at the very beginning of the call was we do have explain and analyze commands. Some situations where materialistic views would be helpful. Different kinds of indexes are involved. So PromptQL will be able to identify top queries coming to a DB and propose a set of indexes that are missing or are not used well. So essentially like coming up with more performant options and optimizations for the DB itself.
Yes. So let me present once again, actually.
Yeah.
So the idea is for yes, absolutely, for PromptQL to be able to do all of this, and it's generally like a free-form interface. So I just tried it out. Like, are you able to run explain SQL queries? So it can like run something like this. You get like a plan. So right now the plan is like sort of doesn't provide like full details on what's happening inside the database itself. But like at some point, like we'll wire it up, and then so you'll be able to see like what you see when you do explain on GraphQL. That's the same thing you will be able to see here. And it will tell you like, hey, this is the exact query that's running in the database. And then you can ask PromptQL that, hey, can you run a few explain statements and try to figure out like what indexes are missing, what are not missing, and then what I can do to improve. So yeah, right now, like it won't be possible out of the box, but generally, yeah, that's the idea.
Very cool. Very cool. Thank you. A couple more questions coming through. I'll wait for Harsh to throw the next one up. Ooh, it's a giant one, but I think this is the one that's talking about GraphQL schemas. But in reality, I think that we don't have a GraphQL schema that's being exposed to PromptQL using a SQL schema instead. Is that right?
Yeah, exactly. So we don't use GraphQL schemas under the hood, and actually, like when we started PromptQL, like that was our first approach. Can we get the LM to produce a GraphQL query and run it against Hasura? And then we ran into these exact challenges that like you're mentioning. So what we instead did was like, since like we already had the platform for a universal data access layer, which could be exposed like any front end that you want, instead of like trying to get an LM to produce GraphQL, it was like actually better for us and the LLM to like build a SQL API and SQL interface over that same data. So just like how you issue a GraphQL query, like, hey, query users where some ID underscore EQ something. Instead, you just write select start from users where ID equals something. But like, so it's just the language looks different, but otherwise the same thing happens under the hood. Same permissions get applied, same connectors get used, all of that. But like now this makes our problem of getting these queries to get generated like much simpler. We don't have to teach the LLM this like custom GraphQL language with custom Boolean expressions, aggregate expressions, all of that. The LLM already knows how to write these SQL queries and knows it like very well. So this reduces the size of the schema that we have to give to the LLM by like a couple of orders of magnitude. So like you can give like 100 tables, 200 tables, and they all fit in LLM context and work fine. So that's kind of the answer there.
Awesome. I think another one that's going to come up next. Yep. So is PromptQL natural language API linked with permissions to not show protected data?
Yes, yes. So if you have an auth header, which is like not blah, but something more sensible, then that will get used just the way like GraphQL permissions get used. So typically when you build your own front-end application, you pass like some sort of JWT or some token from your end client to the API. The same thing will happen with PromptQL. So in like one of the fields, you would pass that token. All the permissions that you define in your Hasura metadata will get applied, and only the data that the client is allowed to access will get returned.
Awesome. All right, I think that's all the questions that we had for you, Abhinav. Thank you so much. Excited to try out that API. And folks, if you're curious about it, we'll have the link in the chat so you can go there as well and try it for yourself. Thanks, Abhinav. All right, chugging along here, folks. Let's go to our next section. Like we said, we're going to continue talking about some product and feature updates. And next, we're going to bring on another familiar guest to the show, Praveen, to talk about web connectors for PromptQL. Praveen, go ahead.
Hey, Rob.
Hey, man. I'll jump out the way.
Cool. Let me share my screen. Give me 1 sec. Yeah. Cool. I'll make this short. So been working on a few web connectors for a specific use case which customers had, which is to like enrich like private data with real-time search. I looked at the state of web search for like these Gen AI use cases, and there are different categories here where you have like traditional web search engines, which is like your Brave, DuckDuckGo, Google Search, Bing, and just like giving you like list of 10 results, URLs, titles, and descriptions. That's your traditional search. And there's this AI-powered search retrieval tools, which is like Perplexity, SearchGPT, Gemini grounded with Google Search and whatnot, right? And the key difference here is they give you like a summary, they do the research in the background and give you like a text artifact, and like you can also like get links on top of that. And there are like other products which does this as well, like Dexa and Tably. But the key difference here is how do you now leverage this for your private data, right? And the question could also be like, hey, why can't I just go and search manually? Why is this required in conjunction with PromptQL as well? Right, so the key use cases are, of course, you have like your private data in databases like Snowflake, BigQuery, Mongo, all of these big data sets, and you want to like ground it with real-time data with the search. Sales team productivity as well, where you have Salesforce data, lots of leads and company and people data, and you want to like enrich that with people or company search in real time, get their social profiles, update it back, and whatnot. So that is another use case that we've seen. And of course, outside of this, just generic research about a particular topic and theme. And because you have access to this Python runtime, it unlocks a lot of these use cases and like reporting and exporting CSVs and whatnot. And of course, the final use case is like, hey, how do I now use this data and then update it back into my private data, especially with the Salesforce context where I might want to just update a field in Salesforce with real-time LinkedIn social profile of a particular lead. So those are the 4 key use cases that I've bucketed into. Just quickly jumping into the demo, I've connected 3 search products here: Brave Search, Gemini grounded with Google Search, and then of course there's Perplexity. And you can like bring DuckDuckGo or any of these combination of these providers. And here's a simple question like, hey, who's the head of sales at company? And just going to go with Hasura. This is a typical question that you would ask with your Salesforce data, where you would actually have a particular company or account that you're dealing with, and then you want to understand who's the decision maker in the company, or who is the CXO or CFO and whatnot. So you want to like get that information in real time. You could obviously do a Google search, but then you have this private data from Salesforce with all these account information and the leads coming in, and then you just want to like understand what the next steps are, and you have to like do searches across multiple sources. Especially with larger companies, head of sales could mean different things, different titles and whatnot. So this does this. So it uses Gemini to get the initial information. It cross-verifies with Brave search as well, and uses Perplexity for final verification. Different results from different providers. Gemini, of course, the more accurate one, has the latest data as well. Brave search results is just does a search with a keyword and gives you like 10 URLs and titles and descriptions. So it can like summarize and extract this data from here. And you have Perplexity will also summarize this information. Pretty similar to Gemini, but then the key difference is their API uses an inferior model, inferior sonar model, which they call, which is different from their UI, which is a interesting observation. So now you could like follow up with, hey, give me Suku and maybe on my social profiles, especially LinkedIn, right? So again, now we'll do another follow-up to actually get this information. You could have asked this in the previous example as well. Now, once you have this information retrieved, you can now use this to like update your Salesforce data to say, hey, I have this particular information which is in real time, and I'm just update a field in Salesforce with that specific information. So let's wait for a couple of these executions, and I'll have another example to go over as well pretty quickly. So you have 3 artifacts created. So you got the quick summary, LinkedIn, and social profiles for both these folks, and already following them. So let me do another quick chat. This time, more of a theoretical theme, which is I'm going to copy this question again to rerun this. Search for latest benchmarks related to enterprise AI, specifically looking at this particular archive site, which is known for the research papers around this. So I'm going to use a combination of these web search results, and it's going to like give me like a summary of what the latest benchmarks are around enterprise AI. This has been like an internal use case for us as well, like to understand what the state of the art, which benchmarks should be run, especially with enterprise data, and then and get a hang of these, right? So you have a couple of artifacts created. So you have, in fact, this is Feb 2025, which is the latest data. So we have a bunch of text to SQL, Spider 2, which is a pretty industry standard. You have all of this data. Now you can obviously export this CSV, work on this, and like maybe even do some navigation with your browser agent. So that's the use case. Pretty interesting to see how customers are using this. And I have written a simple blog post around this with all the links to these different connectors. So do check them out. I'll post this on chat as well. But yeah, that's mostly my demo.
Awesome, Praveen. Really great to see that we can actually start to reach out to the web and provide that context and anything that we're doing with PromptQL as well. I like the idea of being able to kind of update things within the within like Salesforce, wherever it may be, based on information found on the web. I'm curious, how do you think this will perform or make things easier for a user at scale? So like obviously you had Suku and Tanmai, but can you just speak a little bit to how that would expand if it was a much larger number of people?
Yeah, no, we've tried this with large companies where, of course, I said the role name for a particular position could be different. Like head of sales could mean VP of sales or different titles, right? And for these ambiguous results, these web search results are really good because it can retry with different variations of these keywords, and then at scale it can just, and because our PromptQL has a planning and execution step, it plans for these different variations of these queries and then gets you back this data. Maybe you can just go for a quick coffee and then get back all of this data and then update your Salesforce data with that. So, which is much better than like you spending 1 hour researching on web and getting frustrated. So,
yeah, awesome. Especially when I have trouble with every coffee maker figuring out how it works. So, thank you.
Yeah, thank you.
All right, man. All right, folks, we have one more PromptQL feature update, and that's going to be around Zendesk. So we're going to bring Akshaya, who is a familiar guest of the show, and I appreciate that he's taken off his neon green PromptQL hoodie so that I'm not, again, the only one not wearing the neon green. So thank you, sir. How are you?
I'm good, thank you. A little warm, but we'll do. All right.
Awesome.
Cool. So just gonna share my screen. So today we're gonna be looking at how you can use PromptQL on your own personal data and on your company's data. And we're gonna be seeing some cool examples of how you can get PromptQL to do exactly what you want it to do. All right. So once you have the so we're gonna be looking at Zendesk. So some of you who might be following along, we've sort of, based on internal feedback, we've made some changes to how this Zendesk connector works. And now today we're going to be sharing a GitHub link. So you can deploy this for your company and try it yourself. Once you've deployed it, this is how a demo would look like. You come to the SaaS integrations tab, you click on Zendesk, you say you edit to add your particular Zendesk subdomain. You hit save and then you log in. A login is going to ask for an OAuth flow. So you're going to provide your credentials and then that's going to be logged in. Now the status of this Zendesk integration is going to say running. At this point, it's syncing all your data. Now, what I've done is before this call, I'd already gone ahead and synced all of Hasura's Zendesk tickets to this project. So we're now going to look at some examples of what we can do with that. So the first thing is, hey, how do I figure out what the sync status is? Well, remember PromptQL has access to a full programmatic environment. So I'm just going to ask it to run a loop and get me the latest ticket it knows and the latest user it knows, and then keep updating that for me every 5 seconds. So let's see. Okay, we have a memory artifact here, and this is the latest data in my Zendesk, so we are up to date. I'm going to quickly go ahead and open all these other examples, and then we're going to run through them one by one. Count open tickets by assignee. Now, this is fairly straightforward. You can sort of guess that it's going to do an SQL, and then sort of group by and then count stuff. So that's what this does. Okay, here's a more interesting one. Says tickets created by day of week. So I sort of want to know on which days of the week people are creating more tickets. So let's run this and see what it looks like. All right, so we have a table of the days of the week and ticket counts. But here's another trick I sort of learned very recently, which is you can sort of use this text artifact to create these little ASCII graphs. So I can sort of very easily tell now that Monday is the leader, and then people are taking weekends off and sort of dips over the week. Okay, cool. Let's try another simple one. For the last tickets open in the last 4 months, which are already closed, so closed tickets, identify the average time to resolution grouped by the assignee. Okay, and then we sort of generate an ASCII graph as well. So this could be interesting as well. So you could run this on your own Zendesk data. And move on to the next one. This I found quite interesting. So I'm saying which organization has the most open tickets. Now you might know a particular organization that you have in mind, but what I've asked it to do is retrieve the 20 most recent tickets for that organization, put all of the text together, the titles and the descriptions, and then give that to an LLM to give me a report of exactly what's happening with their organization. And when I ran this, it found one of the organizations in Hasura support and gave me exactly what was top of mind for this customer. Told me exactly what the problems were for this customer and exactly what I should do next as next actions. So I think this could be very cool to run across multiple organizations in your support. Let's look at another one. Okay. So here I sort of put together a bunch of different things. I said, let's look at the 100 most recent tickets and go ahead and classify for me yourself, right? So go through each ticket and give it a point rating. Effort you think it might require to solve this ticket. And then group them by the assignee and tell me who has the most workload on their plate by this effort score. So this puts together a bunch of different things. This is going to write the Python program. It's going to loop over each ticket. It's going to do the classification. Now, if you have rules that you think define this notion of effort better, you can also add to this. And at the end of this, it allowed me to sort of see which one of our guys have a larger effort open tickets assigned to them right now. Okay, let's do another one. So this is, I think, pretty complex. I'm going to get this running. So what does this do, right? So we were looking at, hey, if you have a lot of support tickets, which ones of those support tickets can AI already help you begin to answer? And everyone wants to replace their entire support thing with AI agents. But I wanted to see, for at least the 100 most recent tickets, how feasible is that? And I sort of want to get, so the way I went about doing this is, first I wanted to know what are the different categories of these tickets. So the way I did that was to look at the last 100 tickets, take all their titles, all their descriptions, make it one giant text, feed that to an LLM, get back the different categories. And then for each category, for each of these 100 tickets, I then said, hey, do you think that this ticket could be answered by an AI agent or not? And then what I asked it to do is say for each category, look at all the tickets you said could be answered by an AI, and then summarize that for me. So effectively, what this is going to give me, so I'm just going to pull up a result I had run previously in the interest of time. Let me see. All right. So effectively, what it found for me is that, so of the last 100 tickets, these were some of the categories of those tickets. And then, so for example, with database connectivity as a category, when you look at only those tickets that could be answered by AI, these were the common themes, which are things like configuration issues and stuff like that. And then we had stuff about performance, billing, account management, which is repetitive nature, it says, and the structured data involved. So we sort of got a bunch of different categories and how we can amongst that what we can readily answer with an AI agent. So we have the Zendesk connector, the Zendesk data connector for you ready on GitHub. You can jump in here and then deploy this entire project with a few commands. And the GitHub page also has complete instructions on how you can continue using this and a few example questions as well, which we looked at, which you can drop in and check out with your own data. All right, that's the Zendesk data connector. Look out soon because we'll be launching the public version of this where anyone can just sign up for a Hasura account and connect this without actually deploying it. But meanwhile, you're free to deploy this yourself and get rolling with it.
That's exciting. For me, I really liked the kind of almost like dogfooding of AI answering AI. So essentially looking at that bulk amount of data and saying, okay, which of these questions is answerable? I would say to a degree, we've been kind of trying to do that on our side. So for anybody that's on the call, right, we have a docs bot that runs on the documentation sites. And we scrape that every month and kind of go through and analyze and try to say, all right, what themes are approaching or what themes are coming up. But of course, it's awesome to see it done with Zendesk here. So thank you, Akshay.
All right. Okay, see you everyone.
See you. All right, folks, last bit of the call coming up here. I'm going to actually call two people on stage to join me. First is going to be Paritosh to talk about restified endpoints for DDN, which is going to be part of our engine plugins. And then the second is going to be Julian to come on and talk about commenting and collaborating for DDN. So if you two would like to join me on stage, please. Paritosh, how are you? Julian, how are you?
Yeah, I'm fine. How are you? Hey, Julian.
Doing well, doing well.
Hey everyone.
So we've talked about PromptQL really the entirety of this call, but PromptQL is powered by DDN under the hood. So we're going to take a look at some of the new feature advancements that have happened and talk a little bit about creating REST endpoints for your DDN supergraph. And then also, Julian, we'll talk a little bit about collaborating and commenting structure there. So let me unshare my screen and turn it over to you folks. Here, Coach, you'll go first, and we'll just all kind of hang out here. So.
Yeah, sure. So I'll start. So I'm going to talk about the restified GraphQL endpoints in DDN. We already had this feature in our V2, and it was a very famous feature. Like a lot of users actually use this feature to restify the famous like GraphQL queries which were run again and again, and that can be consumed by their REST libraries or whatever they were using. So first talk about like what the restified GraphQL endpoints are. So they are just a wrapper over your GraphQL queries and mutation, and it allows you a new way to actually run the GraphQL queries or mutation on the underlying GraphQL queries and mutation on your GraphQL server. And it simplifies your access to the GraphQL data using standard HTTP methods. Like it will just work like a REST endpoint. And the key benefits is that you can easily integrate this with your already existing clients that your app is using. And with Hasura, you get these for like free. You don't need to write any code. You just have to plug things in and it will work. Yeah, so I will start with the restified endpoints in DDN. So in DDN, we took a slight different approach on how we are going to handle the restified endpoints. We are using a pre-route plugin for handling the restified endpoints. So this is a fairly new feature, pre-route plugins. So pre-route plugins allows you to route the request that is coming to the DDN engine to an external hook. So we have a client which is actually sending some request, and in the DDN engine we have a route handler which will look at the pre-route plugins that it has configured with, and it will check if the request matches with one of the patterns, and it will send the request out to that hook. And that hook will be responsible for actually handling that request. So we can use this to actually create the restified endpoints feature. Now, for this, we need the restified endpoint plugin. And we also wrote one like a simple TypeScript plugin, which is already there. It is open source, so anyone can just use it. It will allow you to integrate the restified GraphQL endpoints in your DDN, and it just works smoothly. You can just deploy it using the Cloudflare workers, which is also like a very performant way of like doing edge functions and things like that. I will quickly jump into the demo. Just give me a sec, sorry. I already have a project which is set up with the restified endpoints, and we have docs for this. So you can just go through this doc and like do this on your own. It's all like you can do this easily in like 10 to 20 minutes. But I'll just show you like how it looks in the metadata and all. So this is the metadata for the restified endpoints. You basically give it a definition, and you set the URL of the external hook that will be handling the request, and then you also set what are the matching parameters, like what will be the path that will be matching against and the methods, and then you configure things like what the request will look like, and what like if you want to append some extra things. For example, like here I am appending additional header, the content type, so that it's actually consumable by the clients which are using this. And we have our plugin here. So if you just go through the docs tutorial, you will also get this. So this is our plugin, which is written in TypeScript, and it has a config.ts. Here's the thing, like you will configure all your GraphQL queries here, and the endpoints which will be actually backing this GraphQL query. You can add more here, and there are some other configurations also. So you can just go through the docs, and all of these are very clear. I will just show you how this works. What I will do is I will first, just one sec, let me get this out of the way. I will just do a local build, and then I will start the local server, and I will show you how it works. So I have completed the local build. Now, what I will do is I will just go into the restified endpoints plugin, and I will just do a Wrangler dev. So what this will do is it will create a local instance for the same Justified Endpoints plugin, and you can just use this. Now, let me start the Hasura as well, the DDN as well. So it will start up the Hasura locally, and we should be able to do a quick test. Hopefully it works. So so basically this is the endpoint that we have locally, and this is the restified thing that we have configured here. And if I send a request to it, it actually gives me back the result. So you can change this, and you can do a ton of things here. Now let's try to see how it is deployed. So for deploying the restified endpoint plugin, you just go into the depot and you just do npm run deploy, and it will deploy it on the Cloudflare, and it will give you the URL, and that URL you will have to put into your env vars for it to be usable. So once it is done, yeah. So correct. So we got our URL. I will just put it in our .env.cloud. It's already there, and then I just need to do DDN supergraph build create. So what this will do is it will update my GraphQL endpoint with the env if there is anything that has changed. Now, yeah, and then we can also test it out on the prod. Like this is our endpoint that we have. This is the endpoint of our application, and this is the last bit. So if I run, oh, okay. So the JW has expired, so I will have to like get a new one. It's very easy. Like, so since we are using the DDN token, so you will have to fetch one from the console. You can use your own authentication, like JWT authentication, or you can also use the webhook. So you won't have to do this again and again. But just for the demo, I will show you how you can use this. Now, if I
It's the public.
I think just 1 sec. I think I copied the wrong thing. Yeah, it should work. Yeah. So we got our results back, and yeah. So basically, this is how you set everything up, and this is how it works. Make sure to go through the docs and like follow the instructions. It's very like, thanks to Rob and the docs team, like it's very clear. And yeah, so if you want to learn more about the pre-route plugins, this is the link. You can just scan it. And if you want to learn more about the restified GraphQL endpoints, you can go here, and like in the docs itself, there is a link to go to the quick start. So
I think everybody internally are big fans of engine plugins in general, and there's a few different choices, not just these pre-route plugins, but we have pre-response and pre-parse. Is that correct as well?
yes, correct.
Yes, so different choices along kind of the execution of any query that comes in or any request that comes in for how you want to handle it and what you want to do. So the world is your oyster. Paritosh, thank you.
Thanks.
All right, Julian, let's close it out, man.
Right, yeah, that was an awesome feature, Paritosh. Congrats. So now I'm gonna continue with some awesome DDN features. I'm gonna share my screen and start, speaking to you about collaboration. And I know this is the end of the talk, so I'm gonna be brief because I'm sure you are familiar with the different version of this feature in many tools. And so yeah, this is commenting on DDN, and the main goal is to improve collaboration between API producers and consumers. You know, you will be developing APIs with DDN, and you are going to have different teams that are going to consume those APIs, whether that's for building a UI or some kind of CLI tool. The important thing for those two teams is to communicate, as in every relationship. So yeah, let's quickly go through this. How to comment. I'm sure you're familiar with how to comment. And as you will see here, you can comment in many places of the DDN console. You can comment on any model. You can comment on any field on them. And also in several key aspects, like, for example, GraphQL root fields that are fixed. You can comment on both the input and the output. and also in many places. So as you will see, you can comment on the Explorer, on GraphQL, on Insights, and on builds. So for example, the Explorer, as I already showed, you have all your models, all the fields that they have, and you can write nice comments that are going to turn into threads so that you can go back and forth between the producers and the consumers of the API. You can also comment on GraphQL. I'm going to be quick. You can also comment on the Insights tab, where you can see performance traces or the platform report. You can comment on those pages as well. They are specific to builds, by the way, as you can see there. So yeah, because when you have many builds, things change. And you can also comment on the build stuff and on all the places that are there. As you can see, you can comment almost anywhere on the app. And yeah, something that's very important when you're collaborating and when you're writing comments is to see the comments that other people are making. And as you will see, there is a new UI element on the console at the top right that's called comments, where you will see the comments that are relevant to your project. So I was really fast. That's a very useful feature. And yeah, you can start collaborating today. You will see the link here on the QR code and also on the chat. So thank you so much for your attention and for staying all the way until here. So
thanks, Julian. I guess it'd be fair to say, right, that the big benefit here more than anything is to kind of have all the conversations happen in one place, right? So I don't have to go back and forth between Jira and Linear and GitHub. I can just kind of have my conversation all inside of the UI. That's awesome. Yeah.
Perfect.
All right, folks, let's end this call with a couple of announcements for things that are coming up. And Paritosh and Julian, you're more than welcome to hang out here with me if you want to wave goodbye to everybody as we finish up with this. So we have, like I said earlier on, our next community call coming up on March 27th. As has been a very big theme of everything we talked about so far today, really for the past few community calls, is making AI not only repeatable, but also accurate. So how can we do both of these things and make things essentially 100% deterministic? That's what we're going to be chiefly focusing on in the community call in March. You can sign up for it right there via the QR code. Additionally, for events that we have coming up, as a reminder, we have a HasuraCon in person on April 16th here in San Francisco. We'd love to see all of you here with us in SF. Additionally, we have a couple of other announcements that are coming up. So this is a new one to me. On March 13th, we have from 5:30 to 8:30 here at our office, our second data agents meetup, where we're going to be talking about driving GTM innovation with AI-driven accuracy. So I'll leave that up for a moment so you can scan the QR code if you would like to, and I'm sure you can find all of this at hasura.io/events as well for any of the upcoming events that we have. As a reminder, we have Discord office hours if you want to connect with us every Tuesday at 10 a.m. Pacific. You can come join me and others as we talk through all the different questions that you may have about Hasura DDN, PromptQL, whatever it may be. Julian Schmo says you can delete any comments from your manager as well that come through, so hey, why not? We also have some helpful links here, so if you're looking to give us some feedback, connect with us via the community, please check those out. Again, probably the biggest thing is going to be Discord, which we're on very often. Also, if you're interested in sharing something you've built with either Hasura DDN or PromptQL and want to promote it, want to talk to it about, how it benefited you or the lessons that you learned as you went through it, hit up that second link, because we have not done a community showcase in a while. And as full as this agenda was, we always love to make room for our community members who would like to demo and share what they've built. Thanks for joining us. Paritosh, Julian, we'll wave to everybody, and we'll see you folks
in the
next one. Thanks, bye.